Third project is large-scale power generation, and this is investigating the use of alternative and renewable gaseous fuels for power generation using gas turbine technology. And this is led by Cardiff's own School of Engineering, and it will characterize and explore various gases and examine their suitability for uses in gas turbines. And it'll involve combusting a variety of gases under simulated gas turbine conditions at GTRAC, the Gas Turbine Research Centre at Port Talbot, where they're able to actually test these alternative gases and see how they perform. This is important in Wales because much of our electricity is actually coming from gas turbines. And the project is going to provide key data for the development of more versatile combustion systems. In other words, combustion systems that can cope with variations in the quality and properties of gases in a more flexible and cost-effective way. This has a rather delightful multicolored flowchart of the research, which I don't expect you to go through in any detail, but it does actually show how they go through various aspects from burner design, for example, fuel analysis and atmospheric experiments. They mix particular gases, put them through a generic burner, do various temperature experiments, and then report back on how the gas turbine system actually responds in the face of these different gases and their different properties. The project partners cover a broad spectrum of power generation scales and technologies, including large-scale end users such as E.ON, small to medium-scale power generators, so two Welsh SMEs, Pearson Energy Management and RefCas, are involved in the project. Chorus is going to advise on available process gases, which are likely to be used for heat and power. That's a big issue for Chorus themselves. And Kinetic will advise on the burner design. And the dissemination is going to be targeted at local and regional SMEs, multinational companies, and of course academics. Next project is SPARC, Solar Photovoltaic Academic Research Consortium. It's always a challenge to find appropriate acronyms. I leave you to judge whether this one's appropriate or not, but I think it'll do. So the aim is to develop new photovoltaic materials for solar energy conversion towards low-cost PV modules. And the low cost is important here because one of the big challenges with all renewable technologies, but particularly with PV technologies, is actually to make them cost competitive. And that is going to be done by exploring both very low-cost dye-sensitized solar cells and thin-film inorganic materials. And the dye-sensitized solar cells are particularly interesting and potentially important because of the opportunities, the potential opportunities to print them, for example, on sheet steel and to use them for a large scale in areas including building cladding. And the approach is not just to develop, as it were, the PV modules themselves, but also include the power electronics, which are essential to extract electricity effectively and efficiently from the modules themselves. It's got ambitious areas, and it plans to produce and to test these novel PV modules on installations and, as I said, develop the power electronics to go along with it. And again, using the language of work packages, there are essentially three here: developing the power electronics, inline thin film deposition, module integration and testing, and then rapid processing of the materials steps that contribute to manufacturing dye-sensitized solar cells onto flexible steel substrates. And this is a very ambitious project. And here in much more detail than I would expect you to take in, given the size of the print on the slide, are the various people involved. It's led by Stuart Irvine at Glyndŵr University, but with partnerships from Swansea, Bangor, Chorus Colours, Dillis, Dysol, Optex Systems, BASF, Pilkington, and Solar Source. So really quite an array of partners. The low-carbon built environment is something which is close to our heart here in the Welsh School of Architecture in Cardiff. And the aim is simply to work with industry in Wales to reduce carbon emissions from the built environment, focusing on developing new construction industry components via the innovative use of energy-generating facades, timber, low energy lighting and consumer goods. And not only to develop the components, but also design packages for low to zero carbon buildings and link innovation in architecture, in building engineering services and renewable energy supply systems. And bringing all these parts of the supply chain together is a not insignificant challenge, and is also going to involve very significant training challenges, because it's all very well to develop these kinds of systems, but we actually do have to have the people in place who can actually install the components, both on a large scale and on a domestic scale. The project will also develop computer-based tools to analyze energy use in large-scale developments, old and new, building on expertise already developed and applied in the Welsh School of Architecture. And it'll develop protocols to monitor and assess energy performance and emissions of buildings and apply them to a range of building types. Because one of the big challenges in the low-carbon area is not only to develop technologies and practices that promote carbon reduction, but also to know what you've done when you've done it and whether it actually worked or not. And development of these protocols for monitoring and assessment is an important part of this. And obviously, the other aspect of it is actually looking at how the programme outputs might influence policy making and the transition to a low-carbon built environment in Wales. And I don't need to remind those of you who are here from Wales that Wales has really very significant challenges in terms of our built environment stock. So as I said, it's led by the School of Architecture. It's a collaboration of universities and research partners, and it aims to work at scales from the components to buildings to actually looking at cities and regions. So it's really a going the full spectrum of scales. To look at performance, planning, design and construction processes, monitoring use, as I said, and then feeding those back. And this little graphic gives you some idea of those areas. So the research partners include Cardiff, as I've said, Chorus, in terms of sustainable building envelopes, Swansea University, who have very considerable expertise in low energy lighting, Cardiff, again, Chris Tweed, my colleague, the use of timber in building construction, monitoring performance, low carbon design solutions, large-scale demand and supply modelling, and innovation, technology deployment and market development.